Changing gear ever so slightly to talk about phase diagrams, in which of course we depict at which temperature and pressure substances, solids, liquids and gases, and the important points are the lines between those areas, because that's where the substance is changing from solid to liquid, or liquid to gas, or even solid to gas. So for pure substance, 3 phases present simultaneously. You just need to know that one. Critical point, normal boiling point, you've got liquid and gas. Normal melting point, solid and gas. Critical point is the point above which the substance cannot be liquefied. So the triple point you should know is all 3. Critical temperature of oxygen, minus 118. What pressure required to form liquid oxygen at room temperature? About 25 Celsius. Well, the whole point at the critical point is that you cannot liquefy the substance past that temperature. So you can't liquefy oxygen past minus 118. In other words, can't do it. Controlling statements are true. They're all about triple points and critical points. So let's draw a pretty little picture. So here the triple point, at this point all 3 can coexist, and it is a particular temperature and pressure. Critical point occurs after a particular temperature and pressure. So therefore we can go through with that knowledge and look at them. So both triple point, critical point depend on substance only, not on temperature and pressure. Kind of like the idea of that. Triple point and critical point increase with a decrease in temperature. No, you decrease the temperature, you decrease the temperature. You don't change where these are. Triple point increases when the pressure increases. No, it's right here at that pressure. It's not going to change when you increase the pressure. And the critical point decreases when the temperature increases. Again, here is the critical point. It's going to be at this temperature regardless of what you do with the temperature. So thus all of those are false. So both the triple point and critical point depend on the substance only. Absolutely. You go from one substance to a different substance, this position and this position change, but for a given substance they are constant. So stuff about sublimation. Well, sublimation is solid to gas. Is the reverse process deposition? Yes, indeed it is. Pressures below the triple point, substances can sublime. Well, let's have a look at what we got here. Here is the triple point here. Pressures below the triple point are here. So indeed, substances can sublime below the triple point. Indeed, that's when they do sublime. So that one looks pretty true to me. Dry ice, frozen CO2, can be liquefied at pressures above the triple point pressure. What if we pretend that this is the phase diagram for that? So dry ice, frozen CO2 can be liquefied at pressures above the triple point pressure. Well, here say pressure above the triple point pressure, and indeed it could be liquefied. So that looks pretty true to me. And finally, ice cannot sublime. Well, of course, this phase diagram actually is that of water, which you could have told from the point that this OM line, the solid liquid line, is pointing slightly to the left. Well, here's ice, and ice can very definitely sublime down there. So as long as you're below the triple point, ice can sublime quite happily. So therefore, the fact that ice cannot sublime is false. So this phase diagram below, okay, so A to A double prime represents melting. Well, that's melting, and then vaporization, that's vaporization. So that looks pretty true. O represents the triple point of the substance. I like that. P represents the critical point. I like that. The path B to B prime represents sublimation. I like that. So all those look pretty good. The substance for which this is the phase diagram cannot be water. Well, water, of course, very, very unusual in that it's a solid to liquid line bends to the left. So this solid to liquid line bends indeed to the left. Thus, this could well be water. So that's the one that is false. According to phase diagram of methanol, which statement is correct? So let's see, solid, liquid and gas. So solid, liquid, gas, methanol, can only coexist. So that's the triple point at pressures above 1 atmosphere. Well, let's see, there's the triple point tucked away there. It is very definitely below 1 atmosphere. So that one is false. Solid methanol sublimes at atmospheric pressure. Well, C. Subliming is where you go straight from solid to gas. Here's 1 atmosphere, and so therefore at 1 atmosphere the solid goes to the liquid, so the solid melts, the solid does not sublime. At 200 Celsius, 1 atmosphere, methanol is a supercritical fluid, while 200 is somewhere in here, which is below 240, which is associated with the critical point, so therefore that is false. There it is right there. It's just a nice little gas that could quite easily be liquefied. Water and methanol have the same relationship between freezing point and pressure, as they both have hydrogen bonding. Well, that is, of course, this line right here. This line slopes backwards for water due to hydrogen bonding. So even though methanol has hydrogen bonding, it's not enough to slope it backwards. It's sloping forward. So this is false. So finally, this one better be true. 1.25 atmospheres pressure. The boiling point is greater than 64.7. Well, here's 1 atmosphere. There's the boiling point, 64.7. So at 1.25 atmospheres, somewhere around here, the boiling point is definitely going to be greater than 64.7 degrees Celsius, because of course boiling point goes up as the pressure goes up.